Good morning, good evening, good afternoon, good whatever time of day it is and whatever part of the world you're at right now. Welcome back. And we're going to go ahead and continue our lesson on quadratics. Excuse me, not quadratics, but quadrilaterals. Today we're going to continue our lesson on quadrilaterals and more specifically rhombus. The rhombus, or if we're saying it plural, it would be rhombi. All right, so once again, I just want to draw your attention to the chart that I went over in a separate video. So just like a rectangle has all the properties of a parallelogram, a rhombus also shares all the properties of a parallelogram, okay? However, there are going to be some slight changes to this. So, well, not changes, but we still have to adjust for the specific characteristics which make a rhombus and not a rectangle. So those first five characteristics, 1, 2, 3, 4, and 5, are still going to be the same as a parallelogram because remember, a rhombus is a parallelogram. Now, a rhombus, the diagonals are not congruent, okay, or not always congruent. However, the diagonals are perpendicular, and perpendicular means that the diagonals are going to intersect to create four right angles. So inside the diagram of a rhombus, the diagonals are going to intersect to create four right angles, okay? So that's what perpendicular means. Now, the last thing is that the diagonals also bisect opposite angles. And remember, bisect means to cut in half, okay? So bisect means to cut in half. So if the whole angle is 80 degrees, then the two resulting angles would be 40 degrees each. Okay, the bisector. And those would be the characteristics of the rhombus. So now let's go ahead and take a look at these two questions here, number 13 and 14. So first, we want to just go through, since we have the diagram here, the two the distinct things that make a rhombus, okay, are that we have our diagonals here, and this intersection that they share, they're perpendicular. So that means that all of these angles are right angles. And if you notice, you basically have a right triangle as well for all of these. Okay? There's a right triangle created and these subparts. So one of the other things that is kind of implied sometimes when you do work on a rhombus is that you're going to have to either use the Pythagorean theorem, or you may have to use SOHCAHTOA, because both of those things apply to right triangles. You may also have to use the 45-45 or 30-60-90 triangle formulas, and that's because inside of a rhombus you'll get four right triangles. Okay. Now the other thing that the diagonals do, okay, is bisect an angle. So for example, angle K, if the entire angle was 100 degrees, then each angle right here would have to be 50 degrees, okay? And vice versa, if we're looking at this yellow diagonal, JL, and we looked at angle L might be 60 degrees. So then these two resulting angles would have to be 30 degrees, okay? So a bisector bisector just simply cuts something in half, whether it's a segment or an angle. All right, so now that we've discussed those things, let's go ahead and take a look at number 13. NK is 7. So we have NK, that's 7. Then it says KL is 15. KL, 15. And they want us to find NL. So they want us to find this. Now, like I said before, we just got done discussing that this is a right angle, okay? So if we're finding the distance, then we're going to have to use the Pythagorean theorem. And I'll redraw the triangle so you can kind of see it a little clearer. This would be K, this would be N, and this is L. This is 7, this is 15, and this would be X, okay? So since we have C and we have B, we're basically trying to find A. So we would have to use C squared minus B squared equals A squared. And then we would just go ahead and fill those in. So 15 squared minus 7 squared equals A squared. That's 225 minus 49 equals A squared. That's 176 when you subtract them. Equals A squared. So A is equal to, A is equal to the square root of 176. And when we simplify that, we can simplify that to say the square root of 16 times the square root of 11. And that would make it 4 square root 11. So NL is 4 square root 11. Okay. All right. So let me erase some of our markings on this diagram. Let's go ahead and take a look at number 14. So for number 14, they tell us angle JMK. Angle JMK. So we're talking about this angle here. And then they're gonna tell us something about angle LMK. LMK, which, if we're looking at the diagram again, that's both of those two little angles make up the entire angle M. And we already know that those two angles, those two smaller angles, are equal, because they're, no matter what angle M is, each one of them is half, and halves are equal. They're equal, okay? They're congruent. So we know already, in order to find X, we simply just need to solve, we need to set our equations equal to one another and solve for X. So we have 8X minus 13 equals 4X plus 19. And matter of fact, let me write our angle statement. So the measure of angle JMK is congruent to the measure of angle LMK. So then we write 8X minus 13 equals 4X plus 19. And we subtract 4X from both sides. So 8X minus 4X is 4X. And then we add 13 to both sides. So that's going to become 4X equals 32. And to find X, we divide both sides by 4. X is going to equal 8. And that's how you use those properties to help you, solve a problem dealing with a rhombus. Obviously, there are other different types of variations of problems that you can use, to solve problems with rhombus, but that's about it. All right, you all have a great day, and see you all back later for another video.